champ, how are you doing? I hope that you are safe and healthy at your home and you are practicing hard for your exams. So champs, welcome again into another amazing session of mathematics, and I'm your master teacher Shubham Gupta. So in this class of mathematics, we are going to discuss about the surface area and volume of the spheres. So make sure that you are making the notes and solving the question with me. So champ, let us start. So champ, in this class, we are going to look about the surface area of a sphere, then volume of the sphere, and also we will discuss about the hemisphere. Then we will look at some questions also. So champ, we know that a sphere of radius r, right? This is the sphere of radius r, and in this one, there is no concept of total surface area and curved surface area. And why so? Because in the sphere, there is no base and the top surface, right? And that is why there is no concept of total surface area and curved surface area. So in the sphere, the surface area of the sphere will be equal to 4 pi r square, where pi is constant 22/7 and r is the radius of the sphere. And if you talk about the volume of the sphere of the same radius r, then volume will be equal to 4/3 pi r cube, right champ? The volume will be equal to 4/3 pi r cube. Now champ, if we talk about the hemisphere, hemisphere is just like the semicircle. Like we talk about the circle, then semicircle. Same, we have seen the formula of the sphere. Now the hemisphere is when the sphere is cut into two equal parts. As we can see in this. As you can see that we are cutting the sphere into two exactly equal parts. Yes, curved surface area, only the curved surface area. But now why we are talking about the curved surface area? Why we are not talking about only surface area? Because champ, as we can see that after cutting the sphere into two equal parts, one flat surface, one circular base have been emerged. As you can see over here, right? And that is why in this one, we have to consider the curved surface area and total surface area. So curved surface area will be half of the surface area of the sphere, 2 pi r square. Now champ, as we can see that after cutting the sphere into two equal parts, one flat surface, one circular surface have been emerged, and we have to consider that surface in the total surface area. So champ, the total surface area will be what? CSA 2 pi r square plus area of the circular base pi r square, that will be equal to 2 pi r square plus pi r square, 3 pi r square. So remember it. Okay? Very good. Now if we talk about the volume of the hemisphere, so we know that the volume of the sphere is what? 4/3 pi r cube. So champ, the volume of the hemisphere will be equal to just the half of that, right? So champ, the volume of the hemisphere will be 2/3 pi r cube. I hope it is clear. Very good. So now champ, let's practice some question now. Look at the first question. What they're saying, the diameter of a sphere is decreased by 25%. Then by what percent its curved surface area decrease? We know that in the case of the sphere, there is no concept like CSA or TSA. There is only surface area. So we know champ, let's say initially curved surface area or surface area is 4 pi r square. Now, if the diameter of sphere decreased by 25%, then we can say that initially diameter was 2 into r, and now is what? Now the diameter is what? 2r minus 2r 25%. That will be equal to 3r/2. So now with respect to 3r/2 diameter, we have to find the surface area. So now champ, if 3r/2 is the diameter, so 3r/4 will be the radius, the half of the diameter. The surface area will be what? 4 pi r square, 9 pi r square by 4. So my initial surface area is 4 pi r square. My final surface area 9 pi r square by 4. They are asking the percentage decrease. We know the formula of percentage decrease. Initial value minus final value divided by the initial value. We will get the percentage change. I hope it is clear. Now, champ, look at this one. The diameter of the moon is approximately 1/4 the diameter of Earth. That means the ratio of the dia of moon and Earth is given to us. Then what is the ratio of volume of moon to the volume of Earth? That means what is given, champ? The ratio of dia of Earth and moon is given to us. They are asking the ratio of their volumes. Now we know that moon and Earth both are spherical, right? So for the sphere, the volume is 4/3 pi r cube. And if we want to find the ratio of the radius of moon and Earth, we will need, that's it. So now, champ, let's say the dia of Earth is small d. So radius will be d by 2. Now, what they're saying, the dia of moon is 1/4 of dia of Earth. So dia of Earth is d. So dia of the moon will be d by 4 and radius will be d by 8. Now, in order to find the ratio of the volume, simple. The volume of the moon will be what? 4/3 pi r cube. The radius of the moon is d upon 8. This is the volume of the moon. Now, same for the Earth. The radius is d by 2. We can find the volume 4/3 pi r cube. The radius of the Earth is d by 2. I will get the volume. Simple, divide both the volume, take the ratio. The d and d are same, pi are same. You will get the ratio of the volume of moon and volume of Earth. And we can see the volume of moon will be 1/64th of the volume of the Earth. I hope it is clear. Very good. Now, champ, look at this one. A cylindrical container of base radius 6 cm has water up to a height of 5 cm. If a metal sphere of radius 2 cm is totally submerged in the water, find rise in the water level. So, champ, we are submerging the spherical, right? We are submerging the spherical metal. So, champ, we can see the volume of the sphere will be equal to the volume of the water displayed in the cylinder, right? So, with the help of that, we can find the volume of the sphere is equal to volume of the water displayed. The water will be displayed inside the cylinder. That is why pi r square h. And h is what? The height, the rise in the water level. We know everything. We can find the height. We can find the rise in the water level very simply. We know the radius. Simple, put the value, you will get the answer. Champ, I hope it is clear. Very good. Now look at this one. Metallic sphere of radius this are given to us, are melted to form a single solid sphere. Find the radius of resulting sphere. Simple. The volume will be equal, right? The volume of all the small sphere will be equal to volume of the largest sphere. Very simply, 4/3 pi capital R cube equal to volume of the small sphere. We know the radius. 4/3 pi will get cancelled out and we will get the R equal to 12 meter. I hope it is clear. Very good. So, champ, now let's summarize our class. In this class, we have seen about the surface area and volume of the sphere. And we know in the sphere, there is no concept of base and the top. But in the hemisphere, one circular flat surface has been emerged. That is why the concept of CSA and TSA. I hope it is clear. So, champ, that's all for this class. Don't forget to practice, stay tuned and be curious. Bye-bye.